everybody. So yesterday I very briefly said something about the chain rule. And today I'm just going to make this video. I'm just going to go through these first four examples. We'll look at the other examples together in class. Yes, let's get started. We're going to be using the chain rule to find these derivatives. I know that there's more information at the top of this page that I did not talk about in class, but I'm not going to go over that right now. I may say something about that in class tomorrow. Well, I'd rather right now just look at some examples of how we actually use the chain rule. So in this first example, number one, we want to find y prime. This function that's given to us, this y here, is a power function. It has an exponent of 3/4 on it. In fact, what is happening in that function is that 5x minus 2, and you don't have to write this part down, is being plugged in to x to the 3/4. So what I was saying yesterday in class, I was talking about a little function going into a big function. That's what's happening here. This x here is being replaced by 5x minus 2. So why we're seeing 5x minus 2 raised to the 3/4. So what we're going to do is we're going to start to take the derivative of the bigger function, the outside function. So we're going to start with the power rule, and we're going to bring down the exponent of 3/4 down in front. Keep the 5x minus 2 on the inside of the parentheses, and the new exponent on that is a negative 1/4 because we subtracted 1 from the 3/4. What the chain rule tells us to do is that because it was not just x on the inside here, we now have to multiply by the derivative of whatever was on the inside of the function. And the derivative of 5x minus 2 is just 5. So this 5 represents the derivative of 5x minus 2. And now I will simplify this derivative by, I'm going to combine the 3/4 and the 5, which is a 5 over 1. Multiply straight across the top to get 15 from 3 times 5. Multiply straight across the bottom to get 4 from 4 times 1. We still have this 5x minus 2 raised to the negative 1/4, which I'm going to rewrite so I do not see that negative exponent by sending it to the denominator with the 4. So now in the denominator, the 5x minus 2 will have an exponent of a positive 1/4. Alternatively, if you so wish, you could also rewrite this as a 4th root in the denominator, since the exponent is 1/4. So either one of these is a perfect final answer. Let's look at example 2. Example 2, we're going to start this example by rewriting this function. Do not use the quotient rule to take the derivative of a fraction just if there's just a number in the top or just a number in the bottom. So if you have a constant in either the numerator or the denominator and only a constant, then you should be rewriting that function, bringing something up from the bottom or factoring something out so that you're not using the quotient rule. So I have rewritten this function with a negative exponent. I brought that 5 minus 4t up from the bottom, and now I'm going to come in and take the derivative. So y prime is going to be equal to, that negative 5 in the front is just going to stay there because of the constant multiple rule. But then when I start taking the derivative of this part, that negative 3 is going to come down in front as an exponent. We're using the power rule. We're going to keep everything that was on the inside of the parentheses, the 5 minus 4t. The new exponent on that is negative 4 because we subtract 1 from our old exponent of negative 3. And what the chain rule tells us to do is that we have to multiply by the derivative of everything that's on the inside of the parentheses. And the derivative of 5 minus 4t is a negative 4. So now we're ready to start simplifying. I'm going to multiply the negative, all the constants, the negative 5, the negative 3, and the negative 4 to give me a negative 60. And then I'm going to keep that 5 minus 4t to the negative 4. And the last thing I'll do is rewrite that without that negative exponent. So I will have 5 minus 4t to the positive 4 in the denominator. So both of those examples, 1 and 2, they're very similar. Only difference is that number 2, I had to rewrite the function before I could take the derivative to get rid of that fraction. Both of those are using something called the general power rule. You see some information about that at the top of this page. General power rule is just a specific case of the chain rule. So, and all that means is that in both in both problems, we used the power rule because we did bring down the exponent and we did decrease our exponent by -1, but we used the general power rule because in both of those cases, it was not just x that we had raised to the power, it was some other function, which then meant we had to use the chain rule and multiply by the derivative of whatever was on the inside of that function. Looking at example 3 now, first thing I want to say is be careful with your notation here. If I meant that the cosecant was squared, I would be putting the squared right there. But that's not what I meant. I put the squared on the end because what I'm saying is that the 5 minus 4 theta is what's being squared. Now, we're not going to use this version, but in other words, I want to make sure we're clear that I'm saying that the 5 minus 4 theta is multiplied by itself on the inside of cosecant. That's what that notation means. It is not cosecant times cosecant. It is the 5 minus 4 theta being squared. Okay, so now let us start with our derivative. Keep in mind then, based off of what I just said, what's happening here is the little function is the 5 minus 4 theta squared that was plugged in to cosecant. So this entire thing here went and replaced that theta. So the big function is cosecant theta. That's what's being plugged into. So to start, we need the derivative of cosecant. And the derivative of cosecant is negative cosecant cotangent. So we have negative cosecant of 5 minus 4 theta squared times cotangent of 5 minus 4 theta squared. Now that we've taken the derivative of the big function, what the chain rule tells us to do is that I now have to multiply by the derivative of 5 minus 4 theta squared. And to take that derivative, we will again have to use the chain rule. So I'm going to bring everything down that we have so far. And now to start taking that derivative in green, we're going to bring down the exponent of 2. We're going to keep the 5 minus 4 theta on the inside of the parentheses. Its new exponent is 1, which we don't typically write. And then on the outside, because it's not just x on the inside here, on the outside, we're going to be multiplying by the derivative of 5 minus 4 theta, which is a -4. And now we're going to clean up this derivative. We have some constants we can multiply and stick in front, like the 2 and the -4. Keep in mind that there is a negative already in the front, so we're going to end up with a positive 8. I'm going to bring down the cosecant of 5 minus 4 theta all squared. I'm going to bring down the cotangent of 5 minus 4 theta, which is squared. And then at the end, in fact, I'm going to move this. I can't. Basically what I'm going to do now is I want to stick this in the front because that is not, why is it doing that? That is not inside of any trig function. And then I'll bring down the cosecant 5 minus 4 theta squared and the cotangent. It keeps erasing, but y'all know what I'm writing, I hope, of 5 minus 4 theta squared. And there's our final answer. Let's look at example 4. Example 4, we have two functions being multiplied together, so definitely we need to be starting off with the product rule. Embedded in the product rule, we will see the chain rule. So I'm going to call my f x to the third and my g the square root of 1 minus x cubed, which is 1 minus x cubed to the 1/2. And I'm writing it like that so we can easily see what we need to do when it comes time to use the power rule. F prime is 3x squared. Take the derivative of that. And then our g prime is going to be, let me grab another color. Bring down the exponent of 1/2. Keep what's on the inside of the parentheses the same. This is us now about to use the chain rule. The chain rule says, oh, I skipped a step. The new exponent on 1 minus x to the third is a -1/2 because we take 1/2 and we subtract 1. Now we're ready for the chain rule. The chain rule says on the outside we have to multiply by the derivative of whatever 1 minus x to the third is, which is a negative 3x squared. The derivative of 1 is just 0, and the derivative of negative x cubed is a negative 3x squared. So now we have all 4 components that we need in order to plug in and use the product rule. I'm just going to clean up our g prime a little bit. I'm going to multiply the negative 3x squared with the 1/2 in the front to give us a negative 3x squared over 2. And then I'm also going to go ahead and stick that 1 minus x to the third in the denominator under the square root, since it has a negative 1/2 exponent. And now let's start doing the product rule. So the product rule says that our derivative y prime is equal to f prime g plus g prime f. And now we're going to start plugging in. F prime is 3x squared. And we're multiplying that by g, which is the square root of 1 minus x to the third. So I really don't even need parentheses here. There's f prime, here's g. And to that, we're going to add g prime f. G prime is negative 3x squared over 2 times the square root of 1 minus x to the third. So that's going to be a minus sign, since it's negative. And we're multiplying g prime by f, which is x to the third. So the only thing I'm going to do to simplify this answer is in that second term, I'm going to combine these two to give me an x to the 5th in the numerator with the 3.